Picking up right where we left off with part 2. So my warm front is an elongated storm over 12 to 24 hours, gives me that gray cloudy day, and often has kind of a drizzly, elongated rain period. Stationary fronts are when my front stalls in a location and it doesn't move forward any longer, which means that it kind of gets stuck in that spot. And from there, it will storm out in that event. And then eventually, over time, it will disperse itself with the environmental air and assimilate into that location. Occluded fronts. Occluded fronts are when a warm front and a cold front meet. And there's two types of occlusionary fronts. We have cold type and warm type in their set. And so really quick, here is an example of an occluded front. So my cold air mass often moves faster in speed than the warm air mass. So the warm air mass is coming forward and the cold air mass is following behind in the space left behind by the warm air mass, which is moving up. And as the cold air mass overtakes the warm air mass, I get an occlusion where the two mix, creating a low pressure center and oftentimes a heavy storm event. And we're coming up on the mid-latitude cyclone chapter where we're going to see occluded fronts occurring, which then creates a rotational air mass and I end up with a big storm event. So in this example, we can see our standard warm front moving in, cold front, and in this example, they're just meeting one another. In this example, they've actually met and began to mingle, right, on our traverse of A and B. And on this part, in my traverse of A and B, they're fully mixing. So my cold air mass, my warm air mass, and my shoving up of the air that is both the warm air and the environmental lapse rate air in that location. What happens when I get an occluded front is I get the combination of both the cold air masses weather conditions of that rapid rain and the warm air masses weather conditions of that gray day. And so I get my combination of a 12 to 24 hour kind of gray storm event coming in with intersparsing of very, very heavy rain conditions or very, very heavy snow conditions. So, for example, some of these snow events that we've had recently, I can expect that all day long I'll have those light flurries, but then I'll have that intersparsing of very, very heavy snow for a period of maybe 3 hours. The key that makes snow events so interesting and different is that in a normal condition, that in rain form would be a no big deal storm event. It would just be a gray day with some heavy rain at times. That rain might add up to maybe being an inch at most. An inch of rain is about 10 inches of snow. And so right away, a kind of heavier rain day can turn into a really major snow event if the conditions are right and cool enough. So I wanted to flick over to this slide because it gives you the difference between the warm and cold of my occlusions in my occluded fronts. So a cold front in a cold occlusion basically will lift that warm front up and over it. And you can see that in this example here. And right here you'll see I've got my sheet cloud conditions and I've got my vertical growth clouds, and I can expect even heavier vertical growth clouds as I continue to push my mixed front up and over and mingle this air mass together. Because of this natural thing, I get both, and this is the most common form of mixed front. Every so often, though, I will get what's called a warm occlusion, and this is when the cold front that's behind the warm front gets to the location, but it can't actually lift the cold air that's in the environmental lapse rate air. So what happened was the warm air mass got there and it started to slide up and over because it's warmer then. And then the cold front got there. But when the cold front arrived, the environmental lapse rate air was colder then. And so its only option was to also, because it is less dense, go up and over. And it creates this kind of mingling mess. Cold front gets pushed up and over these conditions. A lot of times when we get a warm occlusion come into a region, we'll also get a stall out of the storm and it'll get stuck in that one central location. So I'll end up with a stationary front in the place where my warm occlusion occurred, for example. That's something that's quite common actually. So on that note, I'm going to flick back to the original slides from our course, and here we go. So now that we've talked about these mixed fronts, and I showed you the pictures that I like a little better, with a couple word definitions to clean that up a little, I'm going to talk briefly about the dry line. Now, the dry line is something that can be found in other parts of the world, but it's very specific to the United States, and it's very, very common, and it's because of the shape of the United States. It's because of our, I'm going all the way back up to, there we go. It's because of the Gulf of Mexico's location and this continental tropical air mass, which tends to ride up and in, creating a very hot, dry air mass in this location. And so I have desert region, hot, dry air mass along here. And then I end up with this maritime tropical air mass that's very wet, but also warm. And that's pushing up and in and moving northward into the center parts of the United States. And because of this, I end up with sort of an interface between these two air masses called the dry line. And it's specifically the line between humid air and not humid air. They're both warm. On that interface, on that location where that line exists, I actually will get a mingling of the moisture, and it'll create very, very rapid growing vertical clouds, so cumulonimbus clouds, thunderstorm clouds, that will rain out along this line right here, this dry line right here. And oftentimes if you see a dry line, it is bubbles. They're the half suns. They're not going to be colored red. They'll be standard dark or line with no coloring in them. They'll be right next to each other. They'll be right next to each other, where with a warm front, there'll be a distance between my line set. So dry line is a spot where I can have rapid growing thunderstorm clouds. This is incredibly important because we're going to talk about tornadoes and thunderstorms in general, but the United States has some of the greatest number of tornadoes in the world. We get them more rapidly than anybody else. We get them all the time, constantly, every season. The rest of the world does not see tornadoes the way that the United States does. We are the tornado capital of the world, our country is. And it's because of this unique location where we can form this dry line. It creates a natural front where I can get what's called squall line thunderstorms. And those thunderstorm clouds are necessary to be able to create the right conditions to actually form a tornado. And so on that note, we've talked about all our fronts, and this is a very short chapter, but it does have a lot of coursework. So, best of luck. And as always, if you have any questions, please post them in discussion. I'll be checking them. Take care. Bye.